How exactly does the AC installed in our homes actually work? How does this machine manage to make your room as cold as ice even in scorching heat? Let's understand this in 3D. First, let's take a look at the AC setup. It primarily consists of two units, one installed outside your house, the outdoor unit, and the other installed inside your room, the indoor unit. Now, let's see where this process begins the moment the AC is switched on. The entire cycle actually starts right inside your room. The indoor unit houses a long rotating fan known as the blower fan. This fan powerfully draws in the warm air from your room and pushes it directly into the fins of the V-shaped evaporator coil located just ahead. Circulating inside this coil is an icy cold liquid that absorbs the heat from the air just like a sponge. After absorbing the heat from the air, the liquid inside boils and transforms into a gas. This hot gas then travels through a series of pipes directly to the outdoor unit, specifically into this black cylinder known as the compressor. This component is the heart of the system. Inside it, metal spirals trap the gas and compress or squeeze it into an extremely tight space. But what happens when you compress it? Imagine throwing a tennis ball against a wall that is rapidly moving towards you. The ball would bounce back even faster, wouldn't it? The moving metal walls of the compressor increase the speed of the gas molecules in much the same way, causing the gas to heat up to a scorching, fiery temperature. This superheated gas then flows into the outdoor condenser coils. Since this gas is now even hotter than the midday sun, its heat naturally dissipates through the pipes and radiates out into the surrounding air. The fan mounted on top helps expel this heat even more rapidly. As the heat dissipates, the gas contracts once again, transforming into a high-pressure liquid. This liquid then flows back into your indoor unit and passes through a small brass expansion valve. This valve contains a microscopic opening, essentially a pinhole. When the liquid squeezes through this tight opening and suddenly expands into a much larger open space, its pressure drops to zero instantly. In essence, the molecules of the liquid behave like magnets, naturally wanting to cling to one another. When they are suddenly forced to expand, separate, they require energy. They obtain this energy by sacrificing or giving up their own internal heat. The moment they sacrifice their heat, the liquid instantly transforms into an icy cold mist within a split second. And that's it. This icy cold liquid now flows back into the very same evaporator coil where the cycle first began. This continuous loop runs uninterrupted from start to finish until your room is perfectly chilled. But where does the water dripping from the AC come from? Now, pay close attention. Imagine taking a bottle of cold water out of your refrigerator. The moisture in the surrounding air condenses on contact with the bottle, forming droplets of water on its exterior. It works in exactly the same way. When the warm, humid air from the room comes into contact with these freezing cold evaporator pipes, the moisture in the air condenses into water, which then begins to drip from the pipes. This water drains away through a dedicated pipe, thereby completely eliminating the sticky, humid sensation in the room.